Right, so S1 paper, Jan 2013, the old specification, question 7, last question on the paper, a bit of probability, lots of information here, and a few things to find out. So we've got to find the probability of A union B. We're given A and B and the intersection. So A union B is A or B and both, of course. So I need to add up A, which is 0.35, so that's the A. And if I add the B as well, which is 0.45, that's that section. I've actually added that intersection twice. I don't know one of them. So I need to take off an intersection, which is 0.13. And if I work this out, I get 0.67. You actually get this formula in the formula book. So happy days. And then this part B, A dash given B dash. You get this in the formula book. I've got B given A is the intersection of B and A over the A. So this, well, that B dash is going to be on the bottom, which is this yellow area, not in B. The top is going to be the sort of both of them, the intersection of both of them. So A dash and B dash. Which is that bit on the outside, not in A and not in B, means the bit on the outside. Now, of all that bit on the outside is 1 minus the union, because I've worked out what's on the inside of all three of them. The bit on the outside, I just take that off 1 over the B dash. So I'll do 1 minus 0.67, which I worked out before, over the 0.55, which is 1 minus 0.45. It would be 3/5. And then it says the event as C has got probably 0.2, A and C are mutually exclusive, and B and C are independent. And we've got to work out the probability of the intersection of B and C. It tells us in the formula book for independent events, A and B, you just multiply the two individual probabilities together. It's an extension of this formula. It's called the multiplication formula. But if B and A are independent, the probability of B given A is equal to the probability of B. So this should be the probability of A times by the probability of B. So all I need to do is 0.45 times 0.2. Then it wants me to draw a Venn diagram and show the probabilities for the ends A, B, and C. It told us that A and C are mutually exclusive. So I can draw it like this with no overlap with A and C. We know the 0.9 is the intersection of B and C. We know the probability of C is 0.2, leaving 0.11 in there. The intersection of A and B goes in here is 0.13. A is 0.35, so 0.22 goes in there. B is 0.45, so it leaves me 0.23 in there. And then just leaves the outside, so if I add all those up and take it away from 1, I get 0.22. The last part, B union C dash, which means it's not in B union C, so it's not in here, which means it must be one of those two. And that gives me 0.44.